Good evening, students. So those who have not subscribed my channel, please subscribe my channel and also share my videos. So let us move on to the chapter 14, class 12th, Semiconductor Electronics, Materials, Devices and Simple Circuits. So let us move on to the topic, PN junction as a half-wave rectifier. So what do you mean by rectifier? A rectifier is a device which converts the AC signal into DC signal. So it will convert the AC signal into DC signal. So here we have to study about the circuit diagram, principle, working, efficiency and the waveforms. Okay. So let us start with the circuit diagram. Circuit diagram are the foremost important thing in the semiconductor electronics part. In the electronics part, without the circuit diagram, we cannot understand anything. So the circuit diagram here I have shown over here. So it consists of a AC signal which have to be converted into DC. Okay. So the AC signal is passed through this transformer. This is a symbol of the transformer. Transformer is a device which transforms the voltage. It transforms the high voltage at low current to low voltage at high current and the vice versa. Okay. So here the AC voltage will pass through the primary winding of the transformer. Then it will pass to the secondary winding of the transformer. Okay. Then the signal will be passed to the diode. This is the symbol of the diode. The diode symbol looks like this. Diode symbol looks like this. This part is referred as P-type semiconductor and this part is referred as always N-type semiconductor. Okay. So this part is the P-type and this part is the N-type semiconductor. Okay. Then a resistance is placed over here and across this resistance we will get our output. Across this resistance we will be getting our output. Now the principle. To study the principle, let us recall some facts about the PN junction diode. So a PN junction diode is in forward biased when P-type semiconductor is connected to the positive terminal of the battery and when N-type semiconductor is connected to the negative terminal of the battery. So in that case, my PN junction diode is said to be forward biased. Okay, but if P-type semiconductor is connected to the negative terminal of the battery and N-type semiconductor is connected to the positive terminal of the battery, then it is said to be as reverse biased. So this is very important fact and this will be used over here. Okay, so the principle of the rectifier. So on what principle the rectifier works? It works on the principle that a diode offers a low resistive path when it is forward biased and a high resistive path when it is reverse biased. Now, what do you mean by resistive path? The resistive path, what do you mean by it? So, resistive path we can understand by Ohm's law. So, we already know from the Ohm's law, V is equals to IR. Okay, so V upon I will be equal to R. Or I can say R is inversely proportional to I. So, when my diode is providing low resistive path, so it is providing high current to flow. So, it is providing the high current to flow when it is forward biased. Okay, and when my diode is providing very low, it is providing high resistive path, so then it is not allowing any current to pass through it. So that is the case of the reverse biased. Okay, so here resistance is inversely proportional to current. So when my resistance is more, my current is very much low, and that happens in reverse bias condition. Okay, and when my resistance is low resistive path, my current which is flown is very much high, and that is my forward bias condition. Okay, so this is the main principle on which my diode works. This is the principle. Okay, so let us start with the working. So before moving on to the working, let us first understand that what is an AC voltage and what is a DC voltage. So AC voltage or the AC signal is that signal which changes its sign periodically. okay, and it is not having the frequency as constant. But my DC is having a constant frequency and it cannot change its sign periodically. Whatever the voltage is, it will continue to be that voltage only. But in AC, it is an alternating voltage, alternating current, or alternating signal. We can say anything. So in that, the sign changes. In the first half cycle, if the signal is positive, the negative half cycle, the signal will be negative. Okay. So my AC signal is always shown like this. This is my symbol of my AC signal will be like this. Okay. And my DC will have constant voltage throughout. It will be constant signal. So this will be DC. So this signal, this AC signal has to be converted to DC now. So with the help of a rectifier. So PN junction might act as a rectifier. Okay, here the load we have taken as RL. The load can be can be different also. It can be resistive load, inductive load, or capacitive load. Accordingly, the waveforms change. But the load which we have taken over here is resistive load. So in the resistive load, it has got one most important feature, that the current is in phase with the voltage. In the resistive load, the current will always be in the phase with the voltage. Whatever the waveform will be of the voltage, the same waveform will be traced for the current. Okay, it will be not lagging or leading the voltage. Current will not lagging or leading the voltage, but it will be in the same phase with the voltage. So here we are taking the resistive load. Okay, now as soon as I give my signal, so my input voltage signal first is a positive signal. Okay, so here the transformer is placed over here. Transformer is a device which I have already told you. It transforms the voltage. So here we need to transform the voltage, because very high, if very high voltage will come, it will directly go to the diode, and my diode can burn out, because it cannot handle very high voltages. So now in order to step down the voltages, we use here step down transformer. Okay, there are two types of transformers, step down transformer and step up transformer. So here we use step down transformer. Okay, step down transformer is a device which will transform the high voltage to the low voltage at high current, and it will allow high current to pass. So what will it do? It will step down the voltage over here, and it will allow the high current to pass. Now in the starting, my input voltage is positive. My input voltage is positive over here in the starting. Okay, so my input voltage is positive, so my A will have positive terminal and B will have negative terminal in the first phase. Okay, in the first phase, my positive terminal will be A. So now P-type semiconductor is connected to the positive terminal. Here the diode, the P-type semiconductor, the diode having the P-type semiconductor is connected to the positive terminal, means it becomes a forward bias. So whenever it will become a forward bias, it will allow the current to pass through it, because it will provide a low resistive path. Okay, so it will allow the current to flow through it. So my current will flow through it. And ultimately it will flow through the resistor. It will flow through the resistor RL, and as it will flow through the resistor, I will easily get my output voltage, which is similar to the pattern of the input voltage, and this is shown over here. It will be same as that of the input voltage, because my load is resistive load. Okay, it is my resistive load. Now after after 0 to, let us mark it 0, pi, 2 pi, like this, 3 pi. Okay, so from 0 to pi, my voltage is positive over here. So from 0 to pi, I have got my output voltage similar to my input voltage. Now from the pi to 2 pi, there will be phase reversal. There will be phase reversal of the AC signal, and here now my A point will become negative. My now A point will become negative from pi to 2 pi, and positive is from 0 to pi. So it will become negative and B will become positive. So as soon as my A will become negative, my p-type semiconductor will be connected to the negative terminal of the battery, and it will become reverse biased. And we know that in reverse biased, it provides a high resistive path, means it will not allow my current to flow through the diode, and there will be no current through the diode and no current through the resistive load, and there will be no output voltage. So I am getting my output voltage as 0 over here. So I am getting my output voltage as 0. Okay. Now again from 2 pi to 3 pi, my signal will be positive, my phase reversal will be there, and my signal periodically, because my signal changes periodically, it is changing from each period. So from 2 pi to 3 pi, again it will be positive. Again my diode will be, A point will be positive over here, and my p-type semiconductor will be connected to the positive terminal of the battery. So it again becomes my forward bias. Now my diode has become forward biased. Now it will allow the high current to flow through it, because it will provide low resistive path over here. Now as soon as it provides the low resistive path, my current will again flow through the resistive load and give me the output, and so I am getting the same output as that of my input. Okay, and like this it continues. As the signal continues, the output waveform also continues in the same manner. Okay, so if I observe the output voltage and input voltage, in the input voltage, my frequency was changed. In the first half cycle it was positive, and in the second half cycle it was negative. But if I see my output voltage, my frequency is constant all throughout it, and in every half cycle I am getting my output positive, half cycle I am getting output. Okay, so here my signal was AC, and now my rectifier converted it into DC with a constant voltage over here. With a constant voltage it has converted over here. So this was all about the working of the rectifier. Now let us talk about its efficiency. The efficiency is given by DC output voltage to the AC input voltage. The efficiency is given as DC output voltage to the AC input voltage. Okay, so efficiency comes out to be 40.6%. The derivation is not in the syllabus of class 12, but derivation is important for the electrical engineering students, but it is not important for the class 12 students. Okay, so the efficiency, but the thing to be remembered is that how much is the efficiency? Efficiency is only 40.6%. So this means that only the 40.6% of the AC signal is converted into the DC output signal. Okay, it is converted only 40.6. Rest of it is wasted. Rest of the signal is not converted. Only this much signal is converted into DC output voltage, because here we are getting the zeros. In the negative half cycle we are getting the 0. Okay, so this is, so it is here I have drawn for the input voltage. The input current waveform will be also similar to the input voltage, because in the resistive load the voltage and current are both in the same phase. As my voltage is, so is my current. Okay, so if I have to draw the waveform for the input current, then that will be also the same, and input voltage, that will be also, sorry, output current, that will be also same. Okay, now the waveforms I have already shown. So the applications, this diode is only used in the domestic purposes, where we need to convert my AC signals to the DC signals. In the large industries and all, this simple diode is not used. It is only used in the domestic purpose, for the domestic purposes. Okay, so this was all about the PN junction diode as half wave rectifier. In the next session, we will be studying about the PN junction diode as a full wave rectifier. There we use 2 diodes instead of 1. Here we have taken only the 1 diode, and we will see how it works taking the resistive load. Okay, so thank you. Please subscribe my channel and also share my videos. And if you have any doubt, you can ask me in the comment section. Thank you.